Hello, everybody. It's time for another math SAT question of the day. We have Professor Emeritus Seth Chaiken from University at Albany, Joel Chaiken, his brother. We are going to try to figure this problem out. So feel free to pause it and then try it and come back. Okay, welcome back. We're going to go through this relatively quickly, and then some of the backups behind this we're going to do after we're done discussing the problem. What we really want to do is try to get the essence of these SAT questions and help you approach them, because we don't know what's going to be asked on the test. Anyway, here we go. A graph of a line in the xy plane has a slope of 2 and contains it by 1/8. The graph of a second line passes through those 2 points, 1, 2, and 2, 1, a dyslexic person's nightmare. If the two lines intersect at a specific point, AB, what is the value of A plus B? Well, first of all, it's clear that it's not at all obvious what the answer is. Like, you can't answer this question in 10 seconds. There's no way you could answer this. Okay, so what I would do, the way I did this the first time I saw it, is I figured, well, we know that the intersection of two lines is where they cross, so it's not a bad approach to actually try to do it. Put down quarter 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is a question that takes a while to do. Okay, so the first line it goes through the point 1/8. Oh my God, it's all the way up there. I'm wrong. Now it has a slope of 2, so it's a positive slope, right? It's a positive slope. Now notice that, okay, they made you a gift. We're going for the equation of the line,
Yeah.
and it's wonderful. Thank you, Seth. Thanks for putting it in where it should be. They want an equation of a line. The simplest way to write an equation of a line is y equals mx plus b. If you are lucky enough to have the slope and the y-intercept, you could slap the equation down really, really, really easily. And they gave us a gift. Because it's a 1, we're right next to the y-intercept. So we sort of know b, close to the y-intercept, right? And we know it's a slope of 2. So if the y value is an 8, right, and the slope is 2, and you're only 1 away, what does this point mean? That point has to be a 6, right? Because they gave you a gift, because they put you so close to the y-intercept. So we know that it's 2x plus 6. So we have 1 done, okay? Now the second one, they give us 2 points, but it's weird, right? 1, got to be really careful here. 1, 2, let me use a different color. 1, 2, and then 2, 1. Well, you know the slope is negative, right? So we know y is equal to something, right? And then, clearly, b is going to be above the y-axis. B is going to be positive. So now, what's the slope? Well, the slope is 1. The slope is 1. Well, the absolute value of the slope is 1. It's really slope negative 1. And what's the y-intercept? Well, you can sort of see that it's 3. So what I'm doing, and this is really important, open up your ears, it's really important on the SAT to think in 3 modalities when it comes to equations. The algebraic approach, the graphical approach, and the table. Occasionally the table comes in handy. So what I'm doing is I'm going from one to the other. I'm going algebraic to graphical, graphical to algebraic. I'm trying to think in 2 languages at the same time. It's really helpful in these problems to think graphically. And then you immediately get those 2 equations. Now, so the answer would be the intersection point. Well, if you really need, you can actually see the answer, but that's not suggested. So what the 2 lines intersect at AB. So you say, okay, now you have to make an executive decision. You have to say to yourself, okay, I can do this. I can solve 2 equations, 2 unknowns, and I can get the answer. Then I add x, a and b, the x and y coordinates of the intersection. I get the answer. But the SAT is almost never going to ask you to do this. It takes too much time. There's got to be a trick. There's got to be a coincidence. There has to be a pattern. There has to be a special relationship that allows you to see A and B immediately. So you have to make an executive decision. Do you sit there and try to be a genius and figure out what it is, or do you just do by brute force? So I spent maybe 5, 6 seconds saying to myself, I'm not that smart. I'm just going to do it by brute force, even though I know that the better way to do it is to spend more time thinking and being a genius and try to see the special relationship. So I just did it by brute force, but I got a little frustrated because it's got to be a special relationship. It was driving me crazy. So, but it's really nice. And there's a special relationship here. You do the 2 y's. See that y and a y? So you substitute. 2x plus 6 is equal to negative x plus 3. And then you do a plus x on each side. And then you get 3x is equal to negative 3, right? Because you subtract 6. And then you see that what did I do wrong? This is a negative 3. Sorry, it's always, I make a ton of mistakes, okay? Make a ton of mistakes. 3x equals negative 3. So x is equal to negative 1. If x is equal to negative 1, oh god, negative, I hate negative numbers. Oh, well, this one's not too bad, right? If x is equal to negative 1, then y is equal to negative 2 plus 6. So y is equal to 4. So the point of intersection is negative 1, 4, which, by the way, is close to what the graph showed, which is pretty good. So then you add these two and you get the answer 3. Now, I went back and it drove me crazy. I knew there was a genius way to do this. I knew there was. So I went back and I looked at it and I said, oh yeah, now I figured it out. Seth, how long did it take you to see the genius way to do it?
Oh, a bit longer than this video so far.
Well, that's not good. You're a math professor.
What led me to see it was I decided to solve for x and y using the equations that Joel wrote, but instead of eliminating y right away, what I did was transform the equations into the standard form that I like to use to do things without making mistakes. Yeah, and so what I did was, oh, how could I get that back?
Backwards key.
Yeah. There we go. So what I did was, here's what I did. I rewrote the equation here as the equation that I circled. Yeah, I rewrote that as the point. I'm explaining how I got the insight.
No, I know, but the point should be the trick, not how you solve the equation.
Hold on.
Okay.
Hold on. I rewrote this 2x minus y equals minus 6.
Right.
And then I rewrote this one as x plus y equals 3. And then I started to think of eliminating the variables, one of the variables, and I realized, golly. The question is, what is a plus b for the intersection point? The intersection point is certainly a point on on one of the lines. Here is an equation for one of the lines. It tells you what x plus y is for every point on that line. So it certainly tells you what x plus y is for the intersection point. And so the answer is 3. That's where I got the insight. I didn't get the insight until I wrote this equation, x plus y equals 3.
Right. Oh, I see. So first of all, I owe you an apologies for interrupting because I didn't realize that you were going to get it through the inside of writing it. So in other words, by taking the longer approach to solve a 2-equation to unknown by setting it up for elimination, you actually lucked out, right? Because
I wrote it in a way that special features of the problem would become visible.
But you didn't know that ahead of time, did you?
No, I know that because as a mathematician, when you put something in a standard form, any special features would become more visible when it's in a standard form than when it's in a hard to understand form.
Really? I didn't know that. But aren't there different standard forms, like parabolas? They have one standard form to show one thing. They have another standard form to show another thing. So it's not that obvious. It's not that obvious.
The advantage of the standard form that I wrote is that you could quickly read off the determinants.
Yeah, but federally,
it'll tell you right away whether it has.
You're going above level of everyone.
They don't do determinants in the SAT.
Stop. You're going too high in math. Stop.
Okay.
Stop.
Do they do determinants in the SAT?
Of course not. Of course they don't.
Okay.
No way. Nobody knows what
My
a
bad.
determinant is. Anyone watching this video, the chances of you knowing what a determinant are about 0. Forget the sets and determinants. Not a good word to talk about. We do not go above grade level where we are. So that was pretty good, Seth. That was pretty good. So what did I do? I got frustrated. I got angry at the problem. I knew the answer was 3. But I had to go back and I had to say to myself, well, first of all, if you're on the test, you don't do what I did, right? You don't really care. You got the answer, you move on. But it sort of drove me crazy. Like, what genius thing do you have to know to get this answer without solving it?
Okay.
And then
should I talk? Okay, when you were discussing the problem, I thought of another way of seeing the trick.
Okay.
You were talking about finding the slope of the second line.
Right.
Okay, and so what I did was visualize. I used my fingers on the table, the 0.12 and the 0.21. And I visualize what Joel wrote, those 2 points and these 2 red points.
Right.
Okay? And therefore, I realized that the equation for this line is x plus y equals a constant. And then, having realized that because the line has slope -1, therefore the equation has the form x plus y equals a constant.
Right.
The way to find the constant is to plug in for x and y one of the points that's on the line.
Oh, yeah. That's
and
really
therefore I added 1 plus 2 and got 3.
Right.
And I thought, wow, that's great. It's even better that 2 plus 1 equals 3.
Right. Yeah.
So if someone with very quick insight would detect that the line, the second line has slope 1,
right,
and therefore x plus y on that line equals x plus y for any of the points, and the 2 points that are given have x plus y equals 3.
Right.
2 plus 1 equals 3, and 1 plus 2 equals 3.
Yeah, that's a massively sophisticated and smart way to do it. The only problem is that we're big shots, right? We're not sitting there taking the test and basically So this is great to talk about, but that's really good insight. So yeah, some there are a few people who would see that. The way I really had to find this. I was dying. I said I got to find this. What I did is I played a little bit. I knew that these points, right, this AB has to be a solution to the equation. So I put, AB, x is A, y is B, and I do what you're supposed to do in algebra, you substitute. So given the first equation that B is equal to 2A plus 6, that's okay. Second equation, B is equal to negative A plus 3. Oh my God. Whoa, look at this. It's staring us in the face. The key to remember in algebra is if you have an equation and you have a point on that line, that point satisfies the equation. So you can plug that point into the equation. It doesn't matter that this happens to be A and B. That's the whole thing of algebra. You work in symbols. So I put the symbol A and B into this equation, and look here. Oh my God, A plus B is 3, and that's how I saw it. So
the writers of the SAT purposely set up a stumbling block by using A and B in the last sentence. If they X and Y, a lot of kids would have gotten the problem more.
Interesting. Interesting. Yeah. The other thing that's really interesting about this problem is that the first line is really actually irrelevant to the problem. So this first line, this doesn't really ever enter into if you think about it, this doesn't really ever enter the solution. So that's a little bit of a thing, right? That happens sometimes, not usually, but it does. So anyway, do you think we're basically done with? I think we're basically done here.
Yeah.
Yeah. Okay. So now, do you think what we like to do with these videos is we're basically done with the big stuff, right? Like what's the key idea, main ideas.
Yeah.
We sometimes have little extra things at the end of the video to help people with some of the more basic ideas, like how to calculate a slope, or maybe how to do these equations a little slower, right? Do you feel like, Seth, we need to talk at all about, how maybe do it a little slower, how to get these equations, or to do it in a more traditional way?
No.
What do you think?
I think we should watch these and see how they came out.
Okay, so we're basically done with this.
Yeah, we're done.
We're done. Well, have a good day. We hope this was
Oh
helpful.
yeah, you too. Yeah.
This
Yeah,
is
I was
a really
having
interesting problem.
yeah, I was immersing my head in a lot more difficult math earlier today, which is a very
Except, we're still
effective
recording.
way. It's a very effective way of getting sleepy.
Right. Yeah, Seth,
I
we're
took a
still
few
recording.
naps.
We're still recording.
Okay,
Yeah. Okay, so we're done.
we're done.
We're done.
Done.
Okay, I'll see you later.
All right.
Bye-bye.
See you later.
Bye-bye.
Bye bye.